This video will show for juniors, high school children, or junior high school students just getting used to graphing, what it's like to graph polynomials. And what we're going to do here is we're going to generate polynomials x to the n, and they're going to be f to the 0, x to the 0, x to the 1, x to the 2, x to the 3. And from that function, we're going to derive two other functions. One of the functions is called a slope function. The slope function is defined as n x to the n minus 1. In other words, you take the original n value, put it in front, and then reduce the exponent by 1. The generator function actually is the area under that function curve, f of x, up to the point x. And it's defined as x to the n plus 1 over n plus 1. I show a constant here, we'll just assume it's 0 for now. We're going to use the Mac grapher program to demonstrate this. So here's a typical example of, y equals mx plus b. Well, here b is 0 and m is 2. So this is the slope of 2. So that's one of the functions that we could use. We only use x here, but this would be 2x. And if it was 2x, this 2, the x would go to 1. The x would go to 1, and would go to 2 then. There's 2x to go to 2. Okay, so this is a table for values of n from 0 to 3. There's the function 1x, x squared, x cubed. Anything x to the 0 is 1. That's why this is 1. And here for this one, 1 is the slope function. X squared over 2 is the generator function. For x squared, 2x is the slope function. X cubed over 3 is the generator function. X cubed, 3x squared. And the generator function is x to the 4th over 4. For this one, see the 3 came down, and it's x, then you reduce the exponent by 1 to 2, so it's 3x squared. So we're going to use the grapher program from Mac to generate some of these curves, and we're going to look at some of them and see how they look and what it's like about, what they're all about. Functions. If function is 1, that's the line there. Function is x, this is function x. Function x squared. Function x cubed. Notice they all have to go through 1 because x to any power is 1. Now even power, you expect it to be above the axis because minus x times minus x is x squared. And then when it's 3 times, it's minus times minus, which is a plus, times a minus, which is a minus. So the odd ones are down here in this quadrant. The even ones are in the upper 2 quadrants. These are the set of equations that we use. F of x equals x to the n. The slope is equal to n divided by x times the function. And the g, or the generator function, is x over n plus 1 times the function. So let's take an example to show how this works. We say f equals x to the 1th, x to the 0th, I mean. So 1 is the f of x. So f of x, now the way we do it with s is you bring the exponent down, which is 0, and then you decrease this by 1, so it's 0 over x, which is 0. So this down here is 0 over x. So the slope is 0. So that just tells you something very important. No matter what this value is, if f of x was 3, the slope would still be 0 because you always got 0 in the front. No matter what the x, it says for all x, it's 0. So the slope of a constant is 0. Now the area, g I said was an area. So let's look at, first of all, the next one is going to be x, n is 0. f is 1, so it's got to be x. That's this. Now, I said that it was an area. It's the area of the function. Now, let's look how this goes. If x has a value here of x, then the area of this, that's a function, and the area under it is x. X times 1 is x. So if you want to find out what it is here, you just go up there exactly x amount. So you start out with a low value like this, and you got a little tiny value. It's little x times that again here. So this shows that the generator function is y equals f of x, which is x. The other thing that's significant about this plot is the fact that all of these functions must go through 1, because it's just x to a power, and if 1 to any power is still 1. So that's the key to looking at your graphing to make sure everything's all right. So now we'll start to look at some individual curves. This shows that the slope is 1 because this is of the form y equals mx plus b, where m is 1 and this b is 0. So this is the slope, is 1. And the generator function is x squared over 2. X squared over 2. So in order to prove this, what this area is, we have to figure out what this area is. The other thing that I want to talk about is that I showed that G had a C in it, so it should be C plus x squared over 2. And so let's look at what that looks like. Okay, here's different values of C. Same slope, same function. And this function is basically, you look at these slopes and take a look at the slope here, the slope here, the slope here. All those slopes are the same. So it doesn't matter which one of these C's. If it's 0, this one shows Z minus 2, Z plus 2. The slopes are all of them are going to have 0 right here. The generators are going to generate a 0 here. Generators are going to generate a 0. Generators are going to generate a 0 there. And these generator functions for any given x value, say this value, if you go straight up any one of those, they have the same slope. So that is the significance of adding C to the generating function, because it's not unique. Any value of C will do. Now let's go on to looking at that area. The driving function, or the generating function, is equal to the area under the function. We're going to take two cases. One when the function is y equals x. That's this curve. We got to look at the area under that. Or when y equals x squared, we got to get the area under this, which is a little more complicated. But let's first look at y equals x. For any particular point on x, this is x, a triangle. 1/2 the base times the height, x squared divided by 2. So that's why this right here, the generator function, is this parabola. Okay, now let's look at the other function, which is y equals x squared, where that's the function now. Now we got to get the area under this. Now this is a little more complicated, but it's not that bad. We look at the way we figure this out is we draw a rectangle equal x, x, and then up touching the y equals x squared point. So there's a formula that says the area in this section right here in a parabola equals 2/3 of the total area. So that means that we have 1/3 of the area in these two places. So individually, this is 1/6 of the area. So 1/6, and the area is 2x cubed, x 2x times x, 2x cubed. So it's 1/6 of 2x cubed, or it's x cubed over 3, which proves the area function. It's important to see that graphically you can prove this area. It gets more complicated the farther you go, higher up you go, but for these few low cases where you can see easily the answers are under the area. This is showing the area under x squared equals 1/3 x cubed. So that's it for this portion, which is this. So we know if that's x cubed, that for sure the slope is going to have 1 less power. And there it is, it's 1 less power. Remember, you bring the 3 down, and then you take this x and make it to 2, so it's a 3x squared. That's the curve right there. And also for the driving function, the driving function is this to the higher power over the higher power, g x to the 4th over 4. So let's look at this. For sure, these are even power, so they should be above. This right here is the actual function, but both the slope function and the generator functions are looking like parabolas. Now let's think about the fact of the c. There's the same picture where it's x to the 4th over 4 plus c, and there's plus c is plus 1, c is 1, minus 1. Any of these generate this. Generate this. This point, slope, whatever it is, let's say take this point here, the slope is negative. Go down here, it's negative. Go down here, it's negative, and it's the same negative. So any one of them generates this. So there's a family of curves. X to the 4th over 4th plus c generates the family curve generates this x cubed over 3. No, x cubed. Go through this exercise. 2x. So you go through, you find that the slope factor is 2, which is, we see that. And now we want to look at the generation of whatever this thing here is. It looks like a parabola. So how do we do it? We take a point, looking for the area under this. So it's 1/2 the base times the height. So it'd be 2x times x over 2, which would be x squared. And so that generator is x squared. Now to look at the fact that we have the c factors to consider. This is 2x, this is x squared, so this is x squared minus 1, x squared plus 1. So this factor could be any value. Any one of those parabolas will generate the same slope factor. Now comes the good part. All the while we've been talking about simple graphing, you've been learning about calculus. If you take a look at the slope function here, the slope function is really the derivative of f of x, written df dx. You now know the derivative of x cubed is 3x squared. The generator is the indefinite integral of f of x. The plus c represents the indefiniteness. You now know the integral of x cubed equals x to the fourth over 4 plus c. Now, algebra is usually made up of powers of x, or roots, square root, cube roots, and so on, and constants. Now you know the derivative of a constant is 0, so that's if you have to do a differentiation, and there's some constants, and the derivative of those constants are 0, and you just look for the ones that have powers of x. So I purposely did not say anything about calculus in the beginning because I don't want any young students in junior high school to be worried about calculus, because sometimes in the early grades they ask you if you want to take calculus, and I don't want you to shy away from calculus because you think it's hard, because now you know that it's easy. So that was my intention, and I hope it worked. Thank you.